Okay, let's see. Let me get a stream. Let me get a shareable link here. Copy. Okay, shareable link here. Shareable link. All righty. Oh, live meetings. Hello, everybody. Hello again. Oh, that's the wrong video. Hold on. That's the right video. All right, there we go. That's better. How's everybody doing today? Can you hear me? Give me a thumbs up. Say, give me a hello. I heard somebody. Oh, okay, that's good. Somebody's there. Hello. Welcome to Friday. What a crazy Friday it is. I think it's Friday. I hope it's Friday. Yeah, a lot going on in the world. Craziness. Just when you thought things couldn't get crazier. Crazy things in the world. But we're going to try to not be too crazy today. And we're going to talk about a bunch of Unity things. First off, I haven't gone through all of the submissions yet. There's a couple of things happened yesterday, a couple of people that I interacted with and got some last minute things in there, which is okay. We're fine. A couple of things, though, there were still a few people, and I'm assuming that they've got their submissions over on the Unity side, perhaps, but they didn't put in an entry on the LMS side. You need to have both, okay? Because I need to have one submitted on LMS, which is just really just a simple explanation saying, hey, I did the project, I used this, this was my idea, and I did that, and et cetera, and watch out for the goblins sort of thing. And just so I can then put your grade on that. I can't grade things that are just on the Unity team collaborative server. RPI doesn't work that way. So that's why I need your submissions on LMS. Make sure you had one of those. 90+% of you did that. So that's good. A couple of, yes. Exactly. Yeah. If your game was obvious enough without it, everything's good. If it's going to take me an hour to play it because I didn't know about this one, subtle thing, I would hope that you could have warned me, spoiled the game for me perhaps, but warn me about it on the LMS submission. That'll be maybe more obvious in the future ones as well. If you did something specific, or there's a specific technique that you want to call to my attention, or some kind of coding thing that you want to say, oh, this was this particular behavior, this AI I implemented using this pathfinding algorithm, and it wouldn't be obvious from playing the game, but you wanted to call my attention to it as a demonstration of some sort. That's also what that bit is there for. So you can kind of talk about your design decisions and that stuff. Obviously more important now than it was in the simpler one. So I want to have that taken care of. I may still be reaching out to some people. There were still a couple of weird things with regards to how Unity's website was for a couple of people, perhaps. But the good news is, and this is a big thing, that once you start submitting stuff on the Unity Team Collaborate server, it doesn't really matter, per se. Even if you said, oh, okay, if you've uploaded it before and ahead of time and you ran into one last problem that you needed to submit, or, you submitted something late on the LMS side, for example, as long as I've seen the stuff being submitted on the Unity team server, because that's the one that's really kind of doing the time stamping every time you do an update and every time you do a commit there. So if I see, the majority of your work you did all along the way, and you took, starting this weekend when you're going to start working on your the Apple Picker project, that's still part of that same program. I don't want any new projects to be involved in, hopefully, unless you've got some kind of issue, let me know. But once you start, pushing stuff up there, that's the running record of it, and that's good, that will take into account. So even if there's one tiny little bug that you submit an hour after the deadline, and as long as I can see all the other work was submitted before then, that's a good thing. So that can come to your rescue if need be. So the other thing that I will mention now. I didn't really mention beforehand because usually I do not encourage people to take advantage of this on the first project. A couple people did. Basically, for the next 2 projects, and I can't be as lenient on the last project because deadlines are deadlines, you do get 1 day late, sort of no questions asked sort of thing. So no questions, but you have to kind of let me know if something happened, something came up and you just say, well, I need to take that 1 day and submit 1 day late. You can do that. I usually don't lead with that because you don't want to do that on your first project unless something really comes up that, you felt really, really, really strongly about. Because the other projects are obviously going to be more involved, more work, and so on. So if you're going to need to use them, use it for those. I think I might have mentioned it in the syllabus at one point. Go back and read my syllabus again. So that's there if you need that. All right. So hopefully you get it for the next, at least for the next 2. The last project, depending on how we go with the final deadline, because it is, that at that point I have to comply with the institute rules, so I can't really push deadlines beyond the end of the semester so much. So you really can use them for the next 2 projects for the most part. So you get 1 day, not for both of them, but 1 day overall, right? So a bonus day. So think of it somewhere. But hopefully you don't need it. I don't want anyone to, if you can get them done ahead of time, by all means, get your work done ahead of time or on time. And I'll go so far as to say, if you submit early, I will take that into account on your grade. So, if you submit early and there's, some tiny little issue, then perhaps I'll say, well, okay, you submitted early and things were good. And there was, so you would have got a 95, but you submitted early enough. Maybe I'll push you to the, 100 on that. So I like people who submit ahead of time and make progress all throughout, as opposed to waiting for the last minute. So that's that. All right, so let's push the last project behind us as much as we can, because the last project was, it's kind of a quirky, really kind of weird project in that the way we use the engine is kind of odd. It's really about learning a bit of brute force mentality about certain things, because it is, after all, this is intro to game programming, and those are sort of game programming techniques as opposed to just learning about doing stuff in a game engine. Right. So now you have this kind of general feeling for like, oh, okay, in a game where things are moving around, I have to figure out how do things get close enough to one another, and how do they potentially intersect with one another, and how do I deal with that? How do I tell a story given certain limited things, and so on and so on? How do I, make a compelling game given these constraints? Okay. So, but that's all. Now we want to use the Unity engine for a lot more of kind of what it's good at, use it for its physics, use it for its sound, use it for its interactivity, relying on the mouse control, do all those sorts of things, kind of build that in. So let's do that. All right. And that's not what I wanted to transition. Hey, everybody, this is me in the whole room here. I didn't want to do that. I wanted to do this. Okay. This other screen over here. Now, as I mentioned last time, we'd gone through a lot of the collections and sprites and how they related to collections and that sort of thing. But I stopped right here at Unity prefabs. Now, so prefabs are going to be a really, really, really important part of Unity, but also in most game engines and in most programming, you start to think of, developing objects that are more sophisticated than just a component. Like say, we've been building components as scripts and classes, but what if you had like the player or an enemy, more likely, you had, all of the bugs in the game, and they have certain ways to interact, and they have certain ways of, they have certain health and hit points and, all kinds of different things about them. And you want to build these sort of larger objects. We have been using game objects, but what if you wanted to use them over and over again? For example, like say you had a dozen enemies on the screen. You wouldn't want to create one of, maybe you would, but maybe you might not want to create each one of those individually and have to code it up and have to remember to add colliders and do all that kind of stuff that you need to do. So instead, we have this concept called prefabs, and other engines have things as well. They might be scenes, or they might be blueprints, or they might whatever. But this idea of having larger or higher level collections of components and even hierarchies of objects and so on that can form these kind of higher level constructs in your game engine. And in Unity, we call them prefabs. Okay, so what is a prefab per se? All right, so a prefab, Unity allows you to intuitively create these types of duplicates using what is called a prefab. So like in the case of the apple picker game, there's going to be a tree or an enemy or whatever it is, and it's going to be dropping projectiles at our player for our player to catch in its basket or whatever. And these apples, there's going to be lots of them, and we're going to have to somehow keep track of them. We're going to have to somehow create them as the enemy's dropping them, and so on and so on. So for example, in this case, we're going to have an apple prefab. So the prefab asset allows you to store an asset with all of its properties inside this prefab. And the prefab acts as a template to create new instances of the same object in the scene, potentially, or even across multiple scenes. So say you had the apples that were used throughout the game, you could even use them throughout different scenes and so on. Create one version and then create a prefab of that, and then you can use it over and over and over again. Okay, so it's kind of like a shortcut or a template for a particular type of object, right? A more complex object, right? And this is the drag and drop portion of this. So we'll say, okay, well, how do you make a prefab? And I'll leave this in the slides because I'm going to post both these two sections of slides up here today as a reference. But to make a prefab, it's really, really easy. Okay, you basically create a game object in your hierarchy in the scene you're working on, and then you just drag it from the scene into the project window or the asset folder or a prefab folder within the asset directory, and it just automatically makes it into a prefab. At any point after that, you can modify it directly. You can make changes to it as in the template, as the stored prefab, to change all instances, or you can even just change certain parts of it in the scene once you drag that template into your scene. All right, so let me show you how that happens. All right, that'll make life a little bit easier to actually demonstrate it. All right. So here's Unity. Whoops, do not close, don't save, cancel. All right, so here's Unity. What a weird resolution on one screen. That gets weird. And here, actually, let me show you I keep talking about apples and apple pickers and all that kind of stuff. And you might say, well, do I have to do an apple picking kind of game in here? And the answer is no, it doesn't have to be apple picking. It can really be sort of anything that meets certain criteria. And I'm going to post the details along with the presentation as well. Let's see. Let me go to my scenes here. You'll see I have a lot of different scenes in this project. This was this kind of last semester's master project for me. And so in here, I'm going to show you the Scarecrow game. And now since it's October, it's going to be the perfect thing. So let's say I'm going to save that scene. This is my Scarecrow game. All right. And this is slightly more sophisticated than you actually need to submit. This just kind of showed a few more features and whatnot. So this is my Scarecrow scene. And I'll show you the hierarchy for this scene. And in here we have, a couple of things over here up and to the left here. We have the main camera, which you've seen in your other games. You have the canvas, which is potentially going to have our score, high score, game over. If I double click on here, you can see, okay, here's where, if I click on score, this is where the score is going to go. The high score of the game is going to go here. And there's some game over text that gets shown depending on when the game ends, sort of thing in there. Oh, I'm gesturing and all this kind of stuff, and my camera's not being shown. I feel bad now. The event system is in place automatically as part of the canvas. You may have noticed that in your other games as well. We don't create that, but it shows up as part of the canvas. And then there's two important things. There's the enemy. There's this Scarecrow, who is the enemy in this game. It could be an apple tree. It could be whatever you want it to be. It could be a flying nose that sneezes. True story. So people have done that. Don't do it. Not saying don't do it because it's not cool, but it is cool, but it's already been done. So think of things like that. Stork dropping babies that a fireman has to catch. That was a version. Okay, so there's the enemy here, and then there's the player. Now you'll see my version of the player here in this particular game is a little fancy in that it has a couple of different things. It has a gravestone, which is only going to be visible when the player dies. And then it has 3 buckets potentially in the scene here with it. And there's going to be a couple of different ways to manage the buckets, but they're all going to be sort of part of this player. So let me go ahead and play the game, and I'll show you how the skeleton version of it works. Now, I may have to just play it loud because I'm not sure you're going to hear the... Yeah. So I'm just going to kind of turn up my speakers a little bit here. Dealing with this wonderful issue of not being able to share audio. So let's crank my speakers up just a little bit. I'm going to blow myself out of here. So you see certain objects I catch, certain objects I avoid. So the bags I catch and the buckets I can catch as well. They'll give me additional lives. I can catch the rocks, but the rocks don't really do anything. They're just kind of decoys. But I don't want to catch a pitchfork. Okay, if I catch a pitchfork, I lose a basket. Okay. So there's a couple of things going on. Let me stop the gameplay and kind of see that. Or I can show you yet another version of the game, which is a little bit more the classic. I think I have this one here as well. The classic apple picker, my simple tree version. Oh, come on. Drag that from my other screen. So this is another version of the apple picker. And I'll hit play on this one. You can see this one. It has some background music. I don't know if you recognize that from Katamari Damacy. I can adjust my background music here. So this is my start screen. And I can quit the game from here if I wanted, or I can start the game. So welcome to the infamous apple picker game. The score to beat is 25. That's my high score, I guess. And there's just some art here. So I'll click start it up. And now you see I have 3 baskets on the bottom, and apples are dropped by this enemy that's moving across the scene. And they're sort of randomly dropped. If I miss an apple, I lose a basket. And there's a crunching sound. Maybe you didn't quite hear that. If I get to 25, in this case, I think I get a bonus basket. So I get to 25, let's see. Okay. But you'll see if I miss them, I lose my lives and starts over. There are a couple of subtle things that happen. Like if you do miss a basket and miss an apple and the apple hits the ground, all of the existing apples, all the ones that are in the air, they also disappear, just to make it fair. So you don't like lose an apple and then you lose a basket and then you lose another one like in rapid succession after that. So if you ever miss an apple, you lose a basket and destroys all the baskets that are currently there as well. Okay. So a couple of different versions of the game. All right. So in here, you'll notice that, we had those apples that it was dropping all the time. And the apples are prefabs. So I create an apple and then I can use it over and over again. And I can even instantiate it in my code, which means I can create apples through my code. I don't have to place them in the scene. I can instantiate them as prefabs in my scene. All right. So let's go to an empty scene. Let's see, which I should probably do this in our fall project here. So let's get rid of that. And where are we? Sure. Mm-hmm. Yep. Right now, yes. So yeah, don't jump in just yet. Give me a couple of days. You should be starting to think about the next version, right? So you can submit new stuff in a new scene on your new project, right? That would be a better thing to do. And leave the adventure piece of it, leave that behind for now. Okay. Once you get the grade for it, then you can do anything you want for it and integrate it into the game. And if you even want to make it so that, there's I've done Easter eggs in the different versions of the game. So if you, you see later on in the other more like RPGs and platformers, you can kind of jump between different games. You can even go all the way back to the adventure game and then play through there and find a secret door to go back to the apple picker game and things like that. So they all become sort of mini games that can all jump between one another. So yeah, definitely encourage you to revisit it. So the other one is busy on the other side. So let me go back to the slides for a moment, maybe while we're letting it to do that. So working with Unity's prefabs. So the way that you make a prefab on the fly, once you've defined an object that you want to use, like once you've defined, say, the apples or something like that, then in your code, in your script, you use a function called instantiate, right? This is this notion of instantiating an object, kind of, conjuring up one from where, somebody from the ether, whatever. You instantiate that prefab and you put it, and because this is within your script now, you have to give it a place to appear. So you can say instantiate prefab at a position, and then with a rotation. You can do these sorts of things where you can put the apple in the scene at a specific location. And even if you wanted to rotate it or kind of move it around, you can do a little bit of transformation if you want. And then there's another more subtle piece where if you want to create new objects, you want to instantiate objects that are children of other game objects that have some kind of relationship to something in your scene. Like imagine you had, a castle wall that you were building, and you wanted to create bricks that all were part of that wall. The bricks would be instantiated as children of the wall so that the wall would know about all of them. And if you move the wall, then all of the children objects might move with them as well. They wouldn't be independent. Right, so you can instantiate prefabs either independently when you don't give them a parent, or you can instantiate them in such a way that they become children of an existing game object, and we pass it the transform of that game object, which is basically telling it that this is the game object it belongs to. Right, so you can do things like make a wall out of bricks, or randomly place bricks around your scene, or algorithmically decide what's on the terrain or things like that, leave out sections of the wall, all sorts of things. So prefabs, they're, modules that you then use for building up other stuff or using them in the scene. All right, so now this has loaded in the background, I think. Where'd it go? There we go, that one. All right, so we're in our adventure scene here. We still have that left over, but instead I'm going to go to the apple tree scene. And last time we had, oh, look at this. We had some sprites that we left around. We had the snowsuit kid. I'm going to get rid of the snowsuit kid here, snow kid. And then we also had, these kind of cool characters here. Where is this? This looks familiar. Sonic Sprite. I'm not quite sure which game that's one. And does anyone know where? It is? Oh gosh. Okay. All right. I should have known that. All right. Yeah. All right. So let's get rid of most of those. We'll just keep one. Now, so say I wanted to create Mega Man X here, or not. Okay. With this sprite, I'm going to create a. I want to create an army based on this sprite. Let's make that, sort of thing, something like that. So here's our character, and we'll start by naming it something generic. We'll call it Soldier. Right? Pardon all the Mega Man fans. So we have this character here called Soldier. And the initial version was just created by dragging a sprite into the scene. And it doesn't have any sort of behavior or anything like that. Right now, it's just a sprite appearing in the scene. So if I hit play, nothing really is going to happen. It's just going to be right there. Okay. Nothing happens. All right. So let's also cross over a little bit into, because we want to kind of make this a useful thing. So what kind of stuff would we want to add to a player or an apple or the enemy or something like that? We want to do things like add physics to it. So we want to add rigid bodies, and we want to add collision behaviors and scripts and so on to it. So that's the sort of thing we're going to add here. And so let me jump over back to my presentations again for just a second. Not that one here. Okay. And this is sort of the other part. So let's talk about Unity physics basics for a moment here. Rigid bodies and colliders. These are the two of the main types of things you're going to wind up adding to objects to get them to behave in certain ways and sort of automate their behavior and do useful things. So it makes the perfect sense to kind of introduce these at the same time that you start talking about prefabs, right? Because say in the case of our apple tree game, we're going to create these apples that can fall down and collide with other things. They can collide with baskets or collide with the ground or so on and so on. Okay, so let's talk about those. Dropping it and catching apples. So we're going to have colliding apples with baskets, and we have a couple of different concepts that we're also going to introduce called tags, layers, and this handy function called destroy. Right? Just like we could instantiate an object, which is to create an object, we can also destroy objects. You can destroy objects that are already in the scene. So any object that you've created and put in the scene, you can destroy. Or you can also use it to destroy things that you have instantiated. So it's a way of getting things out of the scene. Because you can imagine that, as apples fall off the screen or they go into the basket, you want to get rid of those game objects. You don't want to keep them around necessarily. Okay. So let's talk about collisions. What is a collision? So a collision lets us know when one game object has hit another game object. So collisions require two related components, the collider, which is going to be the thing that tells us how the collision occurs, but then there's also going to be a physics component. And in Unity, we're using rigid body physics. We're using mostly straightforward dynamic rigid bodies that are going to have physics that will cause them to respond, to react to the environment without the player having to do anything, right? So for a collision to be registered, you are going to be using combinations of these colliders and rigid bodies. And usually, each body involved in a collision will have a rigid body and a collider on it. In some cases, you don't have to have a rigid body because you may be just, going into an area of the screen that you're interested in, some area that's a poison gas cloud or something like that. And it doesn't really have a collision that occurs, but the player or the object might cross into that area. So it's sort of a collision or a trigger that's happening there. All right. So the other piece is this rigid body 2D, and any object with a collider that is not static, that is moving around the scene, will usually have a rigid body 2D associated with it, right? And there are two types of rigid body 2Ds. One, which is dynamic. So if it's entirely based on physics controlling the movement, basically like gravity or something like that, it's going to be a dynamic rigid body. If it's a rigid body that is controlled, its behavior, its movement is controlled by a script, so you have some algorithm that's controlling its motion and it's applying forces and doing different things, then you'd use a kinematic rigid body, meaning it would be part of collisions and things, but physics doesn't quite act. It's not physics that's predominantly in charge of the behavior of that object. So for a lot of the time, you can just, kind of get by with just straight up using dynamic rigid bodies and kind of tweaking them the right way. So and then you have the collider 2D on top of those. That's going to control any collisions and how they interact with one another. And it can either be a collider or a trigger. And we'll set those in Unity's editor. All right. And then there's going to be a set of events, just like we had our event, like our start and our update. Those are events that happen automatically in a scene. We're also going to have these collision events that we can rely on automatically. Okay, so let's try some of that stuff before we get into tags and kind of breaking it down a little bit more. So let's do this. All right. So we have our character here, and we wanted this character to be subject to physics. Simple thing is going to happen that we have, this character looks like up should be facing up and down. And so if we want that player to be subject to physics, we want to add a component to it. And that component, we can start typing. I'm going to put rigid body 2D. This is going to be a 2D game, so it's a rigid body 2D. And if I pop out the inspector for here, you'll see there's lots of things you can assign to it. By default, it's going to be a dynamic rigid body. Here's where we set the type: dynamic, kinematic, or static. So if you have something that's like a wall in the room that you want the player to be able to smash into and collide with, but it doesn't do anything, that might be static. If you have a wall that might be moved according to an algorithm that you set, its motion, or maybe a platform in a game that just moves back and forth in space, sort of like, it's weird. Platforms in platformer games, they never just fall according to gravity. They just kind of float around and maybe move left and right, do all kinds of weird things. Those are typical like kinematic rigid bodies. But then things that generally are just subject to physics are dynamic rigid bodies. And through scripts, we can sort of violate all of those rules of thumb that I just gave there. Okay. Most of the other things you can get by with, at least starting wise, you can kind of just leave them to be defaults. But when you want to get into, specific behaviors about, exactly like, is this particular object heavier than some other one? Or how does it respond? Does it slow down over the course of time due to drag? Or does it stop spinning over the course of time due to drag? Or how is gravity affected? Is everything in the scene affected by gravity the same way? Okay. And of course, is there collision detections and so on, and any kind of constraints on its motion and so on and so on. Okay, so now it has a rigid body on it. We just added that there. And if we leave it to all the default stuff, and I just hit play now, automatically in the scene, it will drop. It will just fall straight down because it now knows about physics. So something to point out, something to remember, there is a bit of control for the project depending on, you can define how physics works. Because you can imagine that maybe you have a 3D game and gravity points into the screen instead of toward the bottom of the screen. So how would you control that? You go to edit project settings and look for physics. All right. So in project setting physics, we have a whole bunch of things we can set. Well, sorry, physics 2D. Physics 2D. You have physics and physics 2D. We'll look at physics 2D for now. And you can set lots of things about how the physics engine works. For example, the most obvious one is, how does gravity work? Okay, gravity is a force that points in the y direction down, right? This 9.81 gravitational constant is pointing us down meters per second. So that's right. Yep. Unity is based on metric, right? So Unity is a metric world and it's based on meters per second. There we go. So that is our gravity. Everything else you can pretty much just leave set. I don't think we've really had to change much of this for the most part in most people's projects. Eventually, we are going to start talking about this layer collision matrix because it's a way to kind of tweak what things can collide with other things. Like sometimes you don't want the player to collide with the player's own bullets, for example, right? So you can set up exceptions in this matrix of what things can collide with other things, right? So yeah, maybe the player doesn't collide with other players, but the player does collide with enemies. That would be handled by, turning on and off certain elements in this matrix to see, what collides with what. We'll maybe get to that in a second. All right. So physics for now. Why gravity is pointing down, that's where it's going to point. If I made this positive, gravity would go up. If I made it y0 and x positive, then it would move in the other direction. Move, in the x direction instead of y direction. So you have control over that. So that's good. Now let's put something else in the scene. And let's see, we'll go to images and we have this Lego chest. So what the heck, I'll use the Lego chest. I'll bring it in there. My gosh, it's a huge chest there. So let's shrink that down so I can just grab it. And I'm going to hold the shift key down to scale it uniformly. I'm going to put it right here. And we kind of briefly touched on this the other day in our end scene for our game. We kind of created something like this. So I want the player now to collide with this thing, right? But this thing isn't going to move necessarily. So what I'll do is I'll go to Lego chest, and for sake of argument, I'm going to add rigid body 2D, but make it static because it's not moving. And now, to get the two to collide with one another, I have to add colliders to them. So this one, I'm going to add a component. And if I start typing collide, it'll show me types of colliders. And we have boxes. We want to use the 2D ones, because this is all going to be governed by the 2D engine. So I'm going to have a box collider for this. And I'll select this guy up here. And I'll add a component there, which is another box collider. And now maybe I even do this. I'll edit the box collider because I want it to be, closer, tighter around the actual image here. Right. So if I hit play, this falls down and it stands on top of the box, stands on top of our object here. Now let's get back to prefabs. So I've created these two things, and they don't really have much behavior other than what I built in with the physics engine. So we're going to be able to actually do quite a bit without even writing any script here. So say I wanted to create a whole bunch of an army of my soldiers. All right, so I'm going to want to create prefabs of those soldiers. So in my assets here, I already have a folder called prefab. You would have to create that. So just out of organization here, we're going to have a prefab folder to put our prefabs in. So I could come here and just drag. I could either drag from the scene or I could drag from the hierarchy, and I just drag that into my prefab folder. And you'll see now I have a soldier that is in my prefab folder. Okay. And additionally, you can see now up here in the scene, the soldier that's in the scene actually turned into this little dark or filled in blue cube, as opposed to just a kind of wireframe cube. And that means it is it's an instance of a prefab now, right? So if I came over to here and I just double click on this, now I'm editing the prefab as opposed to going over to the scene. I'll go back and say, click on scenes there and say, now I'm in the scene again. If I click on this, now I'm editing the prefab that's in the scene. If I double click on this one, it's zoomed into that prefab, but I'm still in that scene here. So I'd be modifying that version of it. But if I double click this, now I'm changing the master sort of prefab. So if I came down here and I said, okay, pictures, images, Snow Kid, and I drag Snow Kid over here, boom. Now Snow Kid is in the prefab. And if I go back to the scene, Soldier now has the Snow Kid image because Soldier is based on the Snow Kid prefab, or is an instance of the Snow Kid prefab, which I don't like. So we'll go back and we'll try to undo. I can only undo a certain amount of stuff in the scene. That didn't work, right? So I will say redo, Control Y, redo everything in the scene. And instead we'll come over to the Soldier prefab over here and try to undo that. Let me do that. Not really. All right, I have to do it by hand. Let's fix it. Editing prefabs and the undo, that's one thing where it can get a little bit weird. So let me double check here if anybody's typed anything. Sorry. Your internet is crashing and you can't see the YouTube live stream or Discord. Well, you'll have to watch the buffered version of it then. So tune in. I'm not sure what to. Hopefully, if it crashes and you get back in, hopefully it will be all right. Yeah, it's a tough one. So let's see. Let's come back here and we'll change that prefab. So we'll say, okay, our soldier prefab is open now. You can see soldier prefab, and we'll put the image of, one of the 0 images there again. So we'll take that one, maybe, whichever one that is, and we'll put that there. Much better, back to normal. All right, so now if we went back to the scene, you'll also see, yep, it's correct in the scene again. The same thing goes, it's not just the image, it's even all of the other things that are part of that prefab. Right? So in that prefab, if I change anything about its physics, if I change anything about its collider, if I add scripts to it, anything about its behavior, anything about its scale, its default position. Now you see right now it does have a default position, which is usually a good idea to go ahead and change that to 0, 0. Right. Normally it's a good idea. There it is. Now it's centered in the scene. Normally you don't want to have an offset for your soldier or your prefabs themselves. You don't want any offset right in here. So normally you want that 0, 0. And then in your scene, we'll check where that is. And now it's using that offset there in the scene. So we can move it around to be wherever we want it in the scene. But it doesn't have an additional offset. We want to be careful of that. Okay. So if we're in that scene, going back, assume this is the main scene again here with the basket on it. And say we wanted more soldiers. So what do? We take the soldier and we, from our prefab, and we put another one here and another one here. And another one here, and another one here. And we hit play. And we had a pyramid of soldiers that then all fell. You'll notice they're all still in the scene. You see they're all their names here. They're all soldier 1, 2, 3, 4. And they're all there, and their physics all happens, and their colliders all work together, and so on. And we can do the same thing for the basket. So say we did the basket here, we drag that. Whoops. Let's say I don't drag it from there. If I can do this, I do that. No, if I do that, guess I can't do that. So now we have the Lego chest in the scene, and maybe wanted to put more of those in. So we put those in the scene, we press play. And just like the original Lego chest, they're also all static, and there they go. So now we have prefabs of these chests that are, they all have their own rigid body that are static. So what if we wanted to sort of do this programmatically rather than design the scene by hand? We wanted to actually use that instantiate function that I had that I put in there, right? Because you don't want to, maybe you're not sure how many of these, or maybe you don't know how many baskets or whatever you want in your scene. So let's go ahead. And once again, we will create an empty object and we'll call this game manager. So we're going to have another game manager object. Excuse me. Now this is going to be a little bit tricky because we already do have, in scripts, we have a game manager script, right? So we can't reuse that name. We already have that name used in this project. So maybe you want to be a little bit more specific, and we'll call this one Game Manager 2, just for now. I mean, you can have objects named the same thing in different scenes. They're not going to get in the way of one another. But let's do this way, just to kind of keep things separate. Manager 2, okay? So this is going to be a new script called Game Manager 2. Create and add that one. All right, so this one is specific to this scene versus the other game manager that's in the other scene. But we will go, and I'm going to say, make sure to push this game manager into my scripts folder. So now all my scripts are in there. Be careful about that sort of thing, right? If you have multiple scripts named the same thing, you're going to get potentially odd behaviors. It's going to be whichever one it finds first, it might use, or certain versions of Unity might just complain about it, or chaos may ensue. So try to keep your classes, your scripts, all give them unique names. So we have game manager in our scene now. It's sort of invisible. It's just hanging out, and we'll put it at 0, 0, 0, right there at the center of the scene. It's not going to do anything. It has no visible component. It just has a script on it. And we'll double click on that. Okay. Now, inside of your Unity and your C# scripts, we always have a start function, start method, and an update method. It gives us those two things. Remember, the update is called once per frame, and the start is called when that scene gets loaded or when that object is loaded into the scene. So the game manager is going to start things up. Now we're dealing with things dynamically. We're not going to be creating our own function necessarily to handle a button press. Instead, we're going to rely on the start and update a lot more. And we're even going to eventually be using a function called void fixed update, which is also part of the physics system. Whoops, what the heck happened there? That's another function we're going to start to see more of, right? So when we're doing things that run inside the physics engine, we're going to be using fixed update. Things that happen just once per drawn frame on the screen, we're going to use update for that. And things that happen on startup, we're going to have start for that. So let's do this. We have the game manager, and we're going to want to let it know about our two prefabs. So I'm going to tell it that we're going to have a public game object, and we're going to have two prefabs. We're going to have soldier prefab, and we're going to have public game object chest prefab. And we'll fix my typo there. So the way that prefabs work is, in order to create a prefab, we have one object or a reference to an object that is, why is it still that funny? I'll leave it later. So we're going to have a reference to the things that we want to instantiate. Manager 2, if all goes well, if we come back to Unity here, we'll update automagically. And we'll see that Game Manager 2 now is looking for that soldier prefab and that chest prefab. Those are the things I named it, and I haven't assigned anything to it yet. Now here's where things get a little bit important, as things were always important. It would work to actually grab one of these soldiers and just drag it over here. That's a valid thing to do. You can create one in your scene and then use that as a template, right? You can actually do that. Just move that around. So you can instantiate, you can use things that are in your scene as templates. Okay, so you don't really need to even have a prefab in order to instantiate something, but we prefer them to be instantiated according to prefab. So what we want to do, what I recommend, is that you create your reference here. You're going to say, all right, for the soldier prefab, we're going to use, here's our prefabs. We're going to create this soldier and put that soldier as the soldier prefab. And this Lego chest is going to be the chest prefab. Okay. The good thing about that is now I could, if I wanted to, delete all of these in the scene. I don't need any of these to actually be in the scene. So let's see, Lego chest, soldier, soldier. Delete them all. They're not in the scene anymore. And the game manager still has a reference to these prefabs because they exist in the project, right? So that's why they're, yep. No, right? Because at this point, like if I grab this, put this in here, I can always delete that one because I'm only deleting the one that I instantiated there. Okay, the only way to delete this one is to delete it from the asset folder. This is really... Yes. Oh, see, if you dragged it from here into your... Right. That's what causes a problem, right? Because if you're referencing something that no longer exists in the scene, it has no idea what just happened. It may actually even... It may... let's try that. So I'm going to say, okay, here's the soldier. I put that in the scene. And then I take this and I drag this over here and use that one instead. And I delete this one. So it did get rid of it there. You see? But now it wouldn't give you an error. It wouldn't say anything. It would just get rid of it. And then you hit play, and then you'd go to instantiate it, and it would say invalid object. You'd get really mad. And then at 4 o'clock in the morning, I'd get all these Discord notes about saying, suddenly I can't instantiate any of my enemies. And that's exactly what happens. Okay. So pay attention now so you don't send me Discord messages late at night later. So you want to manage your things that you're instantiating. They should be prefabs that exist in the project within the assets folder so that they exist outside of the scene so that you can then refer to them. Now, there are some drawbacks to that, because when you are creating a prefab or working with a prefab, or you have something in the script of a prefab, it cannot... you have to be careful about how you potentially refer to things that are back in the scene, right? So if this soldier, for example, needed to draw something in a text box, it wanted to update some text that was in the scene, we're going to get a little bit more sophisticated how we express that relationship, how that relationship works there. Okay, so the other thing I'll mention right now is we're not going to do check-ins today, because there's probably some people who are like looking at their watch saying, or looking at their phone or something saying, okay, when the check-in's going to start? Not going to worry about that, since we all just handed in the project and we want to get us kick-started on this new stuff. All right. So don't worry. I will check in with anyone as a result of the project submission. So I'll get a hold of you if I need to. This is the big thing. Okay. So don't worry. Where was I? All right, so we have the game manager. The game manager knows now. Let's put a soldier back in there. All right, boom, there's a soldier. And the game manager script is here, and it's not doing much of anything just yet. But let's do something. Let's instantiate some of these things that we have. So for starters, we'll do the simple thing is we'll just say instantiate, and it's going to ask, what we want to instantiate. It's not going to ask, but we're going to expect to put it in. So we'll say soldier prefab, and it's doing it for us. Now, if I just said this, instantiate soldier prefab, it's going to just assume that I just put it in the scene at 0. So start should. Whoops, I've tried to check. Okay, I don't know why I do that. Oh, because I tried to run it from in there. Didn't actually want to debug anything, but let's go. So I press play. Okay, so a little bit of excitement there. Didn't mean to get the debugger going. We'll talk about the Visual Studio debugger in a little bit. But for now, we'll leave that off. All right. So we're going to come back to Unity here, press play, and I'm going to hit pause once it really starts playing. Okay. So now I've paused the game, and you'll see we have this up here in the hierarchy now. You can see we have soldier, and then in parentheses, clone. Right. So I've instantiated a soldier. It used the name of the prefab, but then just it adds on this clone suffix sort of thing to the name so it knows about it. And it behaves just exactly the same as the soldier did before, but it starts off in the center of the scene. And if I let it continue, boop, drops off the scene, and we can't see it anymore. So let's do that some more. So we'll go to Game Manager 2. And now, more importantly, we will instantiate something for it to hit and stay in the scene. Instantiate. Wow, my typing skills today. Chest prefab. But let's be somewhat more sophisticated. So one of the things we can do with this is we can give it a transformation and a rotation. So if we want to give it a vector 2, we're going to do this, 0, 0. And vector 3. Oh, wait, I say new. Right. So that's going to be a new position that we're going to position at. You'll notice it's complaining because it cannot convert from a Unity Engine Vector 2 to a Unity Engine transform. Okay, that's because it wants the rotation as well. And I'm going to do a bit of hand waving here, because you sort of have to hand wave when it comes to quaternions for a bit. All right. So I'm going to disable, I'm going to comment out my soldier prefab for a moment and just focus on the chest here. So this version of instantiation, I'm going to say instantiate chest prefab, give it a location, which is just a X and a Y, and then it wants a rotation as well. And the way that it wants to get a rotation is in this form of a quaternion. Now, quaternion is a way to present a rotation as not a set of X, Y, and Z rotations, but as a angle and an axis. So there's going to be an axis or a vector that describes what axis we're rotating, and then an angle which tells it how much to rotate it by. We're not going to get into quaternions. You're just going to type quaternion.identity, and that's more than enough for intro to game programming in terms of knowing how quaternions work. We'll talk about them a little bit, but they are definitely a little bit more crazy and sophisticated. So let's even do this. We're going to move this down on the scene. We're going to make it at -3. And we're going to move this, start this off at -3. Right? So it won't be right in the middle of the scene. And we'll save that. Come back over to Unity. Press play. So now, if all goes well, you'll see it's not at the center anymore. It is now 3 down and 3 over. And we have a basket. And if I even click on that clone, you'll see its position up here is -3, -3. And it is scaled according to how it was originally scaled and so on. So it's all good. It's exactly where I want it. So let's get fancier and say, well, maybe I want to create a group of baskets. Okay. Seems like a thing to do, perhaps in our game where we have 3 baskets in our game. We want to create 3 baskets. So I'll go to Game Manager and I will say, all right, create 3 baskets. Obviously, the way to do it is by saying, repeating this 3 times, right? What would be a better way to create 3 baskets? Absolutely. For I equals 0 to I, whoops, I less than 3, and I'm going to even make this for I int I0, I less than 3, I plus plus. That's going to give me a loop that runs 3 times. Way better than doing that 3 times there, right? So that would give me 3 baskets, and they would all appear directly on top of one another, which would be no good. So now I can be fancier and say, well, I want them to appear next to one another. So now, and let's see, I'll even make an offset here for I times 2. So X is now going to be -3 plus this value that's going to change from 0 to 1 to 2 before ending the loop. And so we're going to have a little bit of a calculation in here. So the first basket is going to be at -3 plus 0 times 2. So it's still going to be at -3. The second basket will be, now we'll run through this loop again, and I will be 1. So it'll be at -3 plus 1 times 2, or -1. And then the third basket, which is going to be at I is equal to 2, is going to be at -3 plus 2 times 2, which is 4. So it's going to be at +1. Okay. So we should wind up with, if I've not messed anything up, whoops. I say whoops a lot, don't I? 3 baskets in a row next to one another. How awesome is that? So you can imagine I could build up a whole game level, or I could have these multiple baskets all doing what I want them to do, you know, as a group, even. All right. And I could do the exact same sort of thing with my soldiers. So maybe I have, you know, some number of soldiers that are going to be in here as well. So I'll just instantiate the soldier, and we'll give it a position. But it will be at 0, 3. So it'll be up in the middle of the scene, and then it will drop. Okay. Boom. Now there's a little bit of space in between these two, which is why it kind of fell in this crack here a little bit. Our collision isn't, you know, it's not completely uniform straight across, but our soldier has fallen and got caught on these here. All right. So things are getting interesting. Now there are potential things to catch across the bottom of the screen. We have some objects that could potentially fall as if they were apples, but we need to have something. The other piece of our game is we usually have this sort of thing that moves left to right across the top of the screen. And it's the thing that actually drops the apples and so on. So let's try to create one more cool thing. And so our scene is here. I think I have one more image we can use. We have the snow kid. Of course, let's use the snow kid as the enemy. I didn't even think about that. Oops. So we'll put the snow kid in here. And the thing about this is, my question would be always like, okay, should I use a prefab for this? Should the prefab, should the snow kid be a prefab? And as a designer, sorry, my chair got all misadjusted here. As a designer, I always have a choice. Is something going to be a prefab, or is it going to be just an object that's in the scene? Is there only, you know, how should I do it? Now, there's only going to be one enemy that moves left to right across the top of the screen and drops down whatever it is that's going to drop down as part of our game. So maybe this is just a game object that exists in the scene, and I don't try to create it as a prefab. So we'll let Snow Kid be just a object in the scene. So go ahead, and now I'm going to give him some things as well. So he has a sprite render, and I'm going to add some components to him. I'm going to add a rigid body 2D, but this is going to be a kinematic rigid body 2D because its motion is going to be controlled by a script, not by physics. Okay. And we'll leave that at that. We won't even give it a collider just yet. All right. So if I press play, okay, The snow kid doesn't do anything. The snow kid just stands there looking cute, as snow kids do. Because I've said it's a kinematic rigid body, so it doesn't really do anything. So we want to get into sort of being able to script motion and behavior for this snow kid up here. All right. And now let's talk about ways that we could get snow kid to move. Let me see where I left this. Let's fill out, actually, yeah, this would be better. Let's leave Snow Kid standing up there doing his thing. And let's talk about the collisions. So we kind of set up this collision where we had in the main scene, we have the game manager, and the game manager is creating these soldiers and the chests, and they have colliders on them. Okay. So there is a collision happening that's just according to the physics collision. But now we might want to have something happen, like if the soldier hits the chest, then the soldier should be caught by the chest, or something should happen, but because of that relationship between the two. That's the collision. That's interesting about collisions, right? We use them to resolve those sort of relationships when things touch one another, when they overlap, or they, bullet hits a target, or the player hits the wall, so the player can't get by. It's similar to like when you would say in your adventure game, you said, if the distance is so-and-so, something happened, right? And it's really the physics engine that's going to handle if the distance became so-and-so, something needs to happen. So let's make that something happen. All right. So we have let's go back to our prefabs, and we have, prefabs. We have our soldier prefab, and we have our chest prefab. Okay. So what we need to do is assign some sort of behavior to one or the other of those things. And here comes a little bit of logic and decision on your part, right? Because you have to say what really controls this collision, what is reacting to the collision versus what is being, worked on by the collision, right? Technically, they are both part of, opening in my seltzer here. Technically, both parties are part of the collision, the chest and the soldier. So you might say, well, does what happens to the soldier when it hits the chest? So the soldier decides the soldier should die, or the soldier should disappear. The chest might say, oh, I add one to my score. And it's a little bit of logic for you to determine, okay, whose behavior is it? Whose script does it belong in? And what I mean by that is I'll say, okay, in this case, I'm going to make the decision to say, okay, if the soldier collides with the chest, the soldier will do something. Right? So in order for the soldier to do something, the soldier needs to have a script on it. So we have a new script, and we're going to call this soldier, and it should be capital, soldier behavior. And so we'll create and add soldier behavior. So this is a new script. And I created it on the prefab. So we can go in here and we'll see in assets. I'm just trying to be neat here. Put soldier behavior in my scripts folder. Just going to keep everything tidy. And we'll go to our prefabs again. And Bolt continues to complain in the bottom there. Darn you, Bolt. All right, so we have the soldier again. The soldier has a soldier behavior. And by default, the soldier behavior isn't really doing much of anything just yet. Okay. But what I'm going to do is say, okay, I'm going to create this callback function, this event function that is a built-in function I just happen to know about called on collision enter 2D. It's important to get this name right. On collision, enter 2D. It means this function here is going to be called when whoever I am attached to, like I'm the soldier, this is a soldier behavior, this is a script that is attached to a soldier object. So when the soldier object, something collides with it, this function will get called. Print something collided with me, the soldier. Or I'll even put a soldier. So this is how the soldier will react to this collision. So we'll come back over here. We'll go to the scene. And we'll try to click on the console here so we can see it. All right. Something collided with me, a soldier. So it hit one of these, and then it tipped over and hit the other one. So the soldier actually collided with two things here. This box, or this chest, and this chest. It collided with both of them. Right? And its routine got called. Its event happened. All right. Everybody follow that? All right. All right. Make sure people are paying attention. You have to like respond on. Did you accidentally constrain it, or did you disable the rigid body somehow? Okay. No. The soldier script. Now, even I've done versions of this game where there was no game manager script at all, right? It's depending on how you architect your game, how you engineer your game, you can decide. It's like, okay, everything has its own behavior, and there's really no need for some kind of external, you put the enemy tree in the game, and the enemy tree is the thing that drops apples, right? So its very presence in the game is the thing that kind of starts its behavior off. And then you have the player, which is the player then holds the three baskets. So then the player has its own script, and you just put those two in the scene, and everything else goes off and does its own thing. Right. So whether or not you have a game manager, it sort of will depend. If you have some kind of overarching mechanisms that you need, like sometimes you might get into like, well, okay, is the score system that shows up on the HUD, on the heads-up display, is that maintained by the scene itself, or is that something that really belongs to the player object, and the player is in charge of updating that? So there's some decisions to be made, or else it'd be too easy to do all this stuff. So anyway, okay, so we have the simple case where we have a collision occurring, so we have to decide what do we want to do as a result of that collision. Okay, so one of the things you could do is, for now, we will say that the poor soldier is going to say, if I collide with something, I die. I get destroyed. So we use that destroy function I mentioned before, and we can refer to the game object that we're on. If I say game object now, right, this game object is the game object associated with this mono behavior. Right? I could have said component.gameObjectGet, but this is the game object this component is attached to, right? A component is always attached to a game object. It doesn't exist on its own. So now what will happen if we come to our game? And we press play, is that the soldier will be instantiated, the soldier will drop, the soldier will disappear as soon as it hits that object. Okay, now it must have hit both of them more or less perfectly simultaneously. So this, we're lucky we actually had this happen twice. That was kind of, if they weren't perfectly aligned, it would have just happened once, and the first one would have been the one that got rid of it. So, so that's a case of where, you know, maybe we have apples dropping and they're going to drop down, and if they hit the basket or they go off the screen, they disappear. Okay. So that's one particular thing that can happen. So we have that object there. Now, in our game, the thing that falls are the apple, or in here the soldier. Somehow we have the soldiers dropping. They're like commandos that are jumping out of a spaceship, and they either hit their target or they miss the planet and fall off into space. There, look, we created a narrative, right? These are actually starship troopers that are jumping out of a craft, and you have to catch them as they fall. Otherwise, they fall off they fall off the planet and something happens. So that's whatever. Boy, I never said it was a good narrative. I just said it was a narrative. So in our scene, just to make life interesting, we have to have another case where, okay, the soldier behavior here. Now, if it hits an object, fine, we destroy it. There's probably something to keep track of. But there might be another case where if the soldier goes off the bottom of the screen, we need to get rid of the soldier as well, because it floated off. Or maybe gravity change, where there's some behavior needs to happen to the soldier as it falls off the screen. So we can also do things like in the update routine here, which gets called every frame, we can kind of keep an eye on what's going on to our player, to our game object. So we could say if game object dot transform dot position dot maybe y is less than some arbitrary number on the screen. We'll say it's less than -5. That means did the soldier fall off the screen? And if the soldier fell off the screen, we also have to do this destroy. So we have two circumstances now. One that we have to use during update because there's really no object to hit in this case. Or maybe you could, you could architect your game in such a way that there's some kind of edge collider at the bottom. So you can do it that way. Or you could just check its position and say, okay, if it falls too far, destroy it, right? This is the case in, you jump off the edge of a platform and you fall too far and there's no collider. So that sort of thing can happen. So in order to exercise this, what I'm going to do is I'm going to go back to the game manager. I'm going to instantiate my soldier prefab far enough to the right that it will fall off the platform, or it will just fall past the platform. So we'll see it pop up somewhere in here. Oh, I made it just, I thought I moved it to the right. Weird. All right. Whoops. Didn't mean to do that. It's been a long day. Here we go. Oh, yeah, I did. Wow. I guess I just saw that it was already 3 and I want to make it bigger. And that's how I thought. Make it bigger. All right, so now it's off to the right. Sorry to yell there. It's excitable today too. So we hit play. And it will fall. And it's hard to see. Did it go away? Well, I can look in here and now seeing my hierarchy, I don't see any soldier clone there. So I assume that, yeah, it went away. Or I can even watch here. And I'll hit pause right away. Let's see. Ready and pause. Okay, so the game is paused. There it is. There's the soldier clone. And let's click on soldier clone to see it's at Y is 1.4. And I'll hit inspector just blanked out because there is we're no longer inspecting an object that exists. Right? So 2 ways to clean up after that object. So that object is, we covered a bunch of material on that, right? That object was instantiated as a prefab by the game manager here at a specific location. And then it fell, and its collider is governed by, is causing this to happen. So if the collision happens, it destroys here. If the object falls past the bottom of the screen, which is sort of arbitrary at this point, goes past -5, it's destroyed by this. Right? So a bunch of things happen without an awful lot of code. It's actually reasonably sophisticated. We have a reasonable bit of logic going on in there. Is that pretty clear how that happened, how that worked? And let's see, what time is it? 4:20. It's not 4:20 yet, but we're getting there. We're covering a lot of stuff. So let's give you some really good stuff to try. Okay. So let's talk about this little kid at the top now. Let's talk about the kid for a moment. So, well, we have the option. Yeah, let's talk about the kid. So the snow kid at the top, our enemy in this case, is a rigid body 2D, or has a rigid body 2D, which is a kinematic rigid body. But we're going to even sort of move it around even without, we're going to use it. We're going to be even more primitive than, more primitive than that. We're going to say add a component. And this is going to be, we're calling this enemy behavior. Right? We'll assume this is the enemy here up at the top. So we're going to create enemy behavior. And the enemy, we're going to tweak the enemy. All right. So the enemy is going to move. We want the enemy to move left and right. Right. We have this rigid body 2D, and let's do this the right way. Let's do this the right way. So the enemy behavior, let's say during start, we have a rigid body 2D. So now, how do we get at it? How do we need to tell the rigid body 2D to do stuff in this case, right? Because it's kinematic. It's not going to do stuff on its own. So the first thing we're going to do is we're going to say get component, and we want to get the rigid body 2D component, right? So we can manipulate it. Right, so get component rigid body 2D, and rigid body 2Ds, they're physics components. So how do we manipulate things according to physics? We add forces, we change its velocity, right? So we can change the velocity of the rigid body 2D by assigning something to it. So we'll get a new vector 2. We have to tell it a direction and a magnitude, right? How fast to move and what direction to move in. We're going to combine these two things together. So we're going to say new vector, and we want it to move to the right, which is going to be positive x, right? So I'm going to say, we want it to move how many meters per second? We'll say 1 meter per second to the right. Oops. All right. So it's going to have a velocity 1 meter per second to the right. If that worked. It's funny. Every time I teach the course, and this is I stress this to everybody, that with game engines and you've heard me say this part of the spiel already. Everything changes so fast with game engines, and that by the time you spend a certain amount of time with one, or then forbid you go to another one, you work in a different game engine. I've been working in Godot for the last month or so, and you learn how that one works, and then you kind of try to transfer that back to this one, and you're continuously your processes are continuously evolving. So some of the stuff now that I'm doing with kinematic body 2Ds and static body 2Ds are affected by looking at what's going on with Godot. But you can see over here, sure enough, we have our snow kid over here who's marching off to the right. So I used to, my point of my story about Godot is that before I might have said, because you can, and if you look at the textbook, and I think the textbook is probably now even more out of date by my standards, that we could have moved this object by saying transform dot position plus equals, or manipulated it according to this, or had it in its update routine to actually go and manipulate the position of the game object itself. Right? You can always say transform dot position plus equals something, right? To move a game object. You can directly manipulate it without even involving rigid bodies. But that's sort of a scary, archaic thing, to directly manipulate something's position, to move it around there. You're pulling yourself out of the simulation, and you're just kind of doing a brute force thing. In some games, maybe it makes sense where there's no physics at all involved, but this game is largely a physics game, so we want to be using physics wherever we can. Right? So I'm going to recommend that we do it the right way. In this case, since we have a moving body that is scripted, so we're going to actually manipulate the rigid body 2D. So we're going to change its velocity. So now the velocity got set to move in that direction to the side there. All right. So the velocity is moving in one direction. And now, according to the rules of the game, what's supposed to happen is if that enemy reaches one side or the other of the screen, it's supposed to change direction. Now, a change in direction, anyone want to guess? If I have velocity that is starting off at at 1 comma 0, and I wanted to change the velocity to be the opposite of that, what would I do? Exactly, right? To go in exactly the opposite direction, you just negate or invert the velocity. Now, you could just, if you wanted to remember, we could say, okay, next time if we want to change direction, we would say velocity equals new vector to -1, like that, right? Or we can even, if we just wanted to invert it and we didn't want to hard code it, we could say times equals -1, right? And this is a pretty powerful way of doing it, right? This version here. And that's because what we're doing is we're basically conserving momentum here. We're conserving, there's a conservation of the physics here. We're going to say, okay, it moves directly the opposite, but it doesn't matter what direction or what magnitude, that's all going to be preserved. And instead, I'm just going to go in the exact opposite direction, maintain the direction, maintain the magnitude, the force. All right, so it's just push you back in the opposite direction. We just have to figure out, when do we want to do that? Okay, so that's sort of the part. Say, okay, when do we want to flip the direction? Now, we could say, okay, in reaction, we could say that would happen in reaction to some collision, potentially. Or we could say once it reaches some boundary on the screen, some hard-coded numbers, similarly to how we did with the soldier dropping off the bottom of the screen. So for now, let's take a look at how we would do it in the case of the hitting a boundary or excuse me, going off the side of the screen. So we'll do it inside the update routine here as well. So we could say if transform dot position dot, and now in this case it's going to be the X. Last time it was the Y dropping off the bottom of the screen. In this case we're going to be off the left or right of the screen. If it's greater than some magic number, 7, we'll say, that means we want to move it in the opposite direction. And we might say if transform.position.x is less than -7, which is the opposite side of the screen, we need to do something, right? So we'd have some comments in here. Right. So we go to the right. If we're going to the right and we get past this -7, now we want to change direction. So maybe we just do this. Does anyone see a problem with that? Okay, so how would I do that? Well, I had this one here. Same thing down there? Yep. Okay. So that's right. There's a danger here, though. And let's see. We might get lucky. We might get lucky, and this might work just fine. Sometimes this does work just fine. Sorry, the pause is not for dramatic reason. I was just having a sip of my sparkling water here. So let's try it. Let's go ahead. And we'll hit here and we'll hit play. And this may very well work, but this is the key to one of the trickiest things or things that people also always get kind of stuck with or stuck by. So let's cross our fingers. Maybe it'll work. And it's deceptive if it does work. So our soldier fell off the bottom of the screen. Goodbye, soldier. And this guy's moving right across here, and he's going to hit 7. And sure enough, it worked. It worked just fine, right? And now we're going to go to the other side. We're going to see what happens. And chances are, if that worked fine, this is going to work fine as well. All right. So it works just fine. Seems like it works just fine. However, I'm going to make it not work fine. And I'm not going to make it not work fine in the way that you might think. I'm going to do this. I'm going to say, well, I want the enemy to move a lot faster. So I'm going to say, okay, enemy, you can now move 3 meters per second. Leave everything else the same. You think everything else should be the same, right? Nothing else is just going to move faster. That's all. So let's see what happens. And we'll discuss why once I get it to break. I'm sure at some point I'll get it to break. All right, cranking along. Oh, didn't break. Not yet. There, I broke. He's very confused. What's happening? Okay. Yeah. Right. So I'm gonna repeat that for the sake of the stream. So let me just, and then we can discuss a little bit more, but I want to repeat that. So what's happening is that it moves fast enough that during the course of one update, one frame, it moves far enough in that moment to get past the edge, but then changes direction and tries to come back. But now, for whatever reason, it doesn't get far enough. It doesn't move far enough in the other direction to actually get back on the screen again, or get back on, past that -7 limit. So it changes direction again. So we've set up this situation in our code here to really, all that it's saying is saying, okay, as long as you're past here, flip directions. And if it happens again, flip directions again. And if it happens again, so unless you're lucky enough for this change to get you back over that limit, it will then just flip all the time and keep you going back and forth and kind of jiggling outside the range of the screen. So that's what we just noticed, right? So we have to somehow take into account to say, okay, not only change direction, but make sure that that velocity gets us back on the screen, right? So we'd have to say something like the simplest way to do it is to say, okay, we would just say transform. Oops, that's not what did I do. What did I do here? We would say here that we want to make sure the transform positions .x is the valid one, is moved back onto there, is less than 7, right? So we would make it equals, it could be 6.99, something like that, right? That would make sure that we're back in the range. So we kind of definitely limit that. But we have a problem here, which is that when you're changing a transform, the way that Unity is set up, it says, okay, you cannot just change X or just change Y, the component of that transform, by themselves here, right? So that's why it's complaining. Let's say this should be a valid, you'd think, it was just a vector, we might be able to change just the X. But because this is a transform, we cannot modify the return value because it's not a variable, because this is just a get kind of thing. So we would have to say something like this. And this would be our new X value. And then our Y value would be transform.position.y. So this would force it so that the X would then be in that range and preserve whatever the Y was. And we could actually come down here and do the same thing and just make this negative, right? So that it wouldn't call this again. So force it to make sure that it's on the screen. There's lots of different ways to kind of enforce this, right? I encourage you to try your hand at, coming up with a different version of this. You've done versions where, let's just check the absolute value of the X position to see, is it greater than 7? And if so, change direction, but clamp the value. And, there's lots and lots of ways. But that's the fundamental thing that people do run into with situations, with these sort of end post or goal post kind of situations, where you go slightly beyond the edge of something and then you wind up never able to get back on. Now, I think, so was it, someone had a question, John? Was it, who was? Hmm? It definitely will be, yes. Yes. Right. And this is another, it's a very good point. So for the anyone listening on the stream, the observation is that update is called once per frame. So depending on how fast your graphics card is, or what the refresh rate of your monitor is, or basically how fast your processor is, the amount of the distance that this will cover during the course of one update will be dramatically different on one computer versus another, which is another reason to kind of make sure that when you're doing this, especially if this is something that's happening in the update routine, you have to be extra careful. And that's why, normally we want to be really, really careful about doing anything that is position-based or timing-based inside of the update routine. So that's a good observation. So let's see if hopefully that worked. So now, even though it's kind of bouncing along, it should happily. So even if I set the velocity so fast that in a single update it flew off the side of the screen by 20, it would be okay, because it would say, oh, okay, immediately get it back onto the screen, right? So we're pretty safe now. So the last thing I'm going to do, just to make this extra fun, is to say, okay, we have our enemy, or whatever it is. Maybe this is supposed to be the dropship, but it's some kid in a snowsuit. I don't know why. Luck of the draw. I'm going to make the kid in the snowsuit drop the soldiers. I want to instantiate. I'm going to put the kid in the snowsuit in charge of dropping soldiers. So the game manager used to be the game manager here, and the game manager knew about soldiers. So let's open up the game manager and say, all right, let's see. This is what it would normally do. And I'm going to just comment that out. And let's go to our enemy behavior. And we want to, every so often, drop or instantiate a soldier. So first things first, we have to make sure that the kid in the snowsuit knows about what a game object looks like, or what the prefab looks like. So we'll say game object soldier prefab, and we'll make it a public. And so now here's its instantiation again. And we could do it inside of update here, but the problem is if we did it here, and my computer happens to be running at 144 hertz, so 144 frames per second, that would mean I would instantiate 144 soldiers per second, which would be not great. I don't want to do that. Instead, so let's create a function called void drop soldier. And we know that this is how we drop a soldier. And I'm going to introduce two cool things. And the first one is I'm going to say, well, I want this to drop at the position that the snow kid is at, right? The snow kid is going to be the one that drops the soldier. So first off, I'm going to say game object transform dot position. So now this means that, yes, we're going to dropping soldier means instantiate a soldier prefab at the same position that this game object, the enemy, the snow kid, is at, with no rotations. That means, okay, drop it there. But I haven't yet said, okay, when to drop soldiers. So I'm going to introduce one last thing for you here. There is a wonderful routine called Invoke and Invoke Repeating. So what Invoke Repeating does for you is you say, okay, give it a function or a method to call, and you tell it how often should it be called. So invoke repeating, and I'm going to say, okay, the method I want to have called is drop soldier, and notice it is the name of that method, which is odd, but okay. And the other thing you're going to give it is how often to call it. So let's say every 1.5 seconds. So, oh, wait, no, sorry. We need two parts here. There's an initial delay and then how often to call it. We need two numbers here. And we need to make sure they're floats. Okay, so invoke repeating means call this method after this amount of time and then call it every, right? So it'd be after 1.5 seconds, drop a soldier, and then every 1.5 seconds after that, drop another one. So it's calling this routine over and over again. So what happens as a result? We wind up with, drum roll please, Snow Kid moving on the screen, and a crash. Why did it crash? Someone tell me, why did it crash? This is the other thing you're going to do all the time. Okay. Yours, let's see. In that case, make sure that the this is the name and it's in quotes. Okay, that's the first thing. So what happened in my case is that I've declared this public soldier prefab, but of course, what I didn't do is I didn't say in Snow Kid here, I left this empty. I didn't initialize this game object. So it doesn't know how to instantiate a soldier prefab until I tell it that this is the soldier prefab. This is the thing that you're going to instantiate. Okay. Does invoke only allow methods with no arguments, or can you pass it arguments to run the methods with? Invoke repeating does not allow for arguments. And we're going to move rather quickly away from invoke. So I'm not going to, there's invoke and invoke repeating, and we're going to use them in this project, but there's a more powerful construct called a coroutine. And that one is going to allow us to do a lot more interesting things. So invoke is sort of a first step towards proper kind of threading and multitasking-ish, multiprocessing and so on. But so invoke is just a convenient first step into that. And it's really just a way to say, okay, this just sort of happens in the background at some fixed rate. So it's sort of like having a special timer function that we can use. All right. And the simpler one, if you said invoke, it just means call this function after this amount of time. Now you notice, okay, yay. And this one, boom, that one actually hit that. That one hit that. So now, just as of today, we have some of the basics. We have our Snow Kid enemy that's dropping soldiers and changing behavior at the top of the screen. We have some baskets that, if they were able to be moved by the player, we could, do something more sophisticated with. But we're also doing the right thing with regards to our rigid body elements here. We've demonstrated basically all, in the end, the Lego chest rigid bodies would be also, they're static right now, but ultimately they're going to be kinematic as well, because we're going to have a script that's going to move them around according to the mouse's motion. Okay. But we've demonstrated at least a static rigid body 2D, which does not move, but has a collider. We had a dynamic rigid body, which is the one on the soldier, because it has real physics associated with it. So it can move. And we also had the kinematic rigid body on the Snow Kid enemy in the scene here, because that one has physics going on, and we are changing its velocity to move around. And yet we are doing it in a script. Okay. So pretty thorough, if I do say so for ourselves here. Introduction to the three main types of rigid body 2D. Also a little bit about collisions. We got collisions in there today. Did a little bit with physics, a little bit with, boundaries and kind of hard-coded boundaries. Covered a lot of territory today. Instantiation, can't even forget, instantiation and prefabs. We had that covered as well. So that was a good day. And we're running a little bit over, so I'm going to let everybody go unless you have any particular questions. Have a great weekend. Lots of food for thought. Start playing around with these. Come up with a good theme for your next project. What type of things does it make sense? Like I said, it could be anything. It could be, skeletons throwing pitchforks, or, what did I have? Scarecrows throwing pitchforks and rocks, or ships dropping space troopers, or noses dropping boogers, whatever. Have some fun. Think of your project and take it from there. And if I can't get your project on Unity team, I'll be in touch with you. Have a great weekend. Stay safe. If you are eligible to vote, make sure you're keeping track and taking care of any type of absentee ballots and getting out there. We're starting to get time towards our national election. Want to get people voting, make their opinions heard. And that's that. Unless anyone has any other questions, have a great weekend. You too. Take care. You too.